Hello, I'm Eamon Macklin. We're going to be analyzing some functions. So we're just analyzing the relationships, which means we don't have to get all like into it. So let's just take our first one, bring it up here. F of x equals x minus 2 times x minus 3 times x plus 1. Each of these is a solution, so x equals 2, x equals 3, then x equals negative 1. Then we just have to find these. So dark red, we'll circle x equals 2 and look for it. A doesn't have one, so we'll just put an x on it. B does have one. C has one. And D has one. Next, we need to, so three of these have one. Next, we need to look for x equals 3. Uh, B does not have one. C does not have one. And D, it does have one. It's really hard to see, but if I zoom in, you can see it right there. A, B, and C are already off the list, but for just for fun, we'll look for x negative 1, 2, and oh my gosh, what would you know? Look at that. D has it. Okay, cool. So our answer is D for 51. Uh, that's all you really have to do for all these. 52 f of x equals x times x plus 2 times x plus 1 times x minus 2. Uh, so this one, it's the same exact thing, except we have this x in front, which automatically means that this x equals 0, x equals negative 2, and x equals negative 1, and then x equals 2. Anyways, let's take a look for where all these are. We'll, circle all of these in a color and find them. So x equals 0. D's already off the list, and either way, x doesn't equal 0 in here. But if you look at B and C, B has x equals 0, and C also has x equals 0. Uh, Next, we need x equals negative 2. We'll make it purple, just because we're like going down a list just to keep it. Anyways, x equals negative 2. C has it. B also has it. Uh, so got to keep looking. X equals negative 1. Uh, B does not have that, so we'll draw a big old X right there. However, C does have that, and so we already know which one it is, but once again, we'll go to the end. Uh, X equals 2. Look at that. C has it. We'll write it over here. D. C. Okay. This is getting kind of messy now. So let's move these elsewhere. Start doing them down here. H of x. This is g of x. H of x equals x plus 2, x plus 3, x minus 1. So once again, same old routine, x equals negative 2. Just move them all to the other side of the imaginary equation sign. X equals 1. There's no x in front of this one, so we don't have a 0, which also means it's not x to the fourth. This is an x uh, cubed equation. This equation, the leading exponent is a 3, which means it's going to look like this. Whereas this one, it would end up as an x to the fourth. Our leading exponent would be 4, so it would be more parabolic, and it's positive, so it would open up like this, which if you look at C is exactly what it does. And then D, there's only 3 x's, which means that the leading exponent is a 3. And so this one, it's also positive. It would look like this, which, look at that, it does. Uh, so we can already deduce that our answer is probably going to be A, because B, the leading exponent here is 4. So this one, we can tell it's going to be A. And if we look at our solutions, x equals negative 2, Here it is over here, this middle one. And then get x equals -3. Here it is. I'm not going to bother looking at b yet. X equals 1. Here it is. So a is 53 right here. Okay. And finally, b. It's obvious that 54 is going to be b, but once again, I'm going to show you why 54 would be b on a question like this. K of x equals x. So here's our x equals 0, x minus 2, x minus 1, x plus 2. So there's 4 x's indicating that this is going to, our leading exponent would be a 4. Um, uh, so, x equals 0, x equals 2, x equals 1, x, go behind our map right here. Why do I have this map? Okay, whatever. X equals -2. So let's just get our colors out again. X equals 0, B, all right, we gotta erase a little bit over here. Okay, where's our pointer? Okay, X equals 0, there it is in the middle. X equals 2, it's a nice purple. X equals 2 right here. X equals 1 right here. And then finally, x equals -2. That's all you have to do for analyzing the relationships. Understand that when there's 3 x's like these ones, there's 3 values right here, that our leading exponent is going to be x cubed. A function that has this as the leading exponent, it's going to look like that. Um, as x gets closer to negative infinity, so does y. And as it gets closer to positive infinity, y also does. Uh, whereas ones like these uh, that have 4 x's, they would do this. And it's going to open upwards. Wow. And see how it's positive. It goes up like a, normal linear function, uh, which would look like that, It's just x. Um, and then this looks like x squared, which is just this, x squared. So understand that. That makes it a lot easier because, I mean, we could, when we're at 53, we could see that it's going to be a just because there's 3 x's, uh, and a is the only one that looks like looks like a cubic function. So, yeah, that's analyzing relationships between functions. Hopefully this made sense. Thank you for watching.